Alright guys, today's goal, the learner will understand how to calculate combinations. Combinations, a selection of objects in which the order chosen does not matter. So yesterday we talked about permutations, meaning order mattered. Today the order does not matter. So let's take a look at that. So, you want to buy 4 different Blu-rays, you can only afford to buy 3. How many different combinations of the movies are possible for you to buy? So let's think about that. Doesn't matter the order in which you select the movie to buy? No. But if you have movies A, B, C, D, which way could we buy? We could buy A, B, C, A, B, D. You could buy B, C, D, and A, C, D. So it looks like 4. I think that's it. So let's look at this equation here. Okay. If we set that up here, it would be you have 4 movies, choosing 3, 4 permutation 3 divided by 3 factorial. Now, I don't know if you've picked up on the pattern yet, but for permutation, you can figure out what's 4 minus 3, 1. That means you include everything except for the number 1. Okay, so you would say 4 permutation 3 is 4 times 3 times 2. And 3 factorial, 3 times 2 times 1. Well, these cancel each other out. What's 4 divided by 1? 4. Isn't that what we ended up with 4 ways? Okay. So let's set up this one here. 6, choose 3. You have, so it would be 6 permutation 3 divided by 3 factorial. And that would be, so 6 permutation 3. 6 minus 3 is 3, so that means you cut out 3, 2, and 1. So you go 6 times 5 times 4 divided by 3 times 2 times 1. So what does that equal? Well, you can say that's 1, that's 2, that's 1, that's 2. 2 times 5 is 20, times 2 is 40. 2 times 5 is 10, times 2 is 20. So there's 20 combinations. So 10 choose 2, so you would have 10 minus 2 is 8, so that means you forget 8, 7, 6, 5, 4, 3, 2, 1, so you just have 10 times 9 divided by 2 times 1. 9 times 5, 45. Now, guys, if you can't do this, so let's set this up. I'll do this one the long way. So you have 5 permutation 5 divided by 5 factorial. Well, 5 minus 5 is 0. That means you don't get rid of any of them. And if you're struggling, look up the permutation equation again and find it. But you can calculate 5 permutation 5. So the top would be 5 times 4 times 3 times 2 times 1. The bottom, 5 factorial, is 5 times 4 times 3 times 2 times 1. Well, if they all cancel, what is it? 1. There's only one way. Think about it at the choice of the movies. If you had 5 movies and you're choosing 5 movies, how many different ways could you choose to watch all 5? One way. Order doesn't matter. They're not saying the order in which you watch them. They're just saying the order in which you buy them. Or, I'm sorry, not the order in which you buy them, but just buying them. Okay? So let's take a look at some other examples. You are choosing 10 of 30 friends to invite to the party. Can you count the possibilities using permutations or combinations, and why? Okay. So would that be a permutation or a combination? Does the order in which you select a friend matter? No. So you would say combination, because order does not matter. Now, if we were to calculate this, we had 30 total people to choose from. We chose 10. So that would be 30 permutation 10 divided by 10 factorial. So 30 minus 10 is 20, so that means you forget 20 to down, so you have 30 times 29 times 28 times 27 times 26 times 25 times 24 times 23 times 22 times 21 divided by 10 factorial, which is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Times 1. That would equal this one. I need to use a calculator for. So 30,045,015 ways of choosing different groups of friends. That's a lot. All right, let's take a look at the next example. You have 12 marbles in a bag. Each marble is a different color, including red and blue. So every marble is different, but they're telling you there's one red and one blue for sure. You draw 2 marbles at random. What is the probability you draw a red marble and a blue marble? Okay. So first of all, we need to figure out how many different total ways could we pick marbles. So how many total do we have? 12. To get one red and one blue, does it matter the order? No. So, and I'm choosing 2. So we need to know how many different ways can you pick 2. So you would say 12 permutation 2 divided by 2 factorial. Well, 12 minus 2 is 10, so you forget 10, 9, 8, all the way down to 1. So you would say 12 times 11 divided by 2 times 1. 1, 6, so that would be 66 ways. Well, if there's only one red and one blue, how many ways could we, so the probability now, how many ways could we possibly get one red and one blue? Well, 1. Because it doesn't matter the order. So you have a 1 in 66 chance of doing that. Okay, so permutation order matters. Combination order does not matter. Those are the key things. Okay? This is your homework problem. Read it over. Bring it in. Hopefully you'll be finished. See you guys tomorrow.